All right, everyone. Welcome to the wasmCloud Wednesday for Wednesday, January 11th, second community meeting of the new year. Woohoo. And we're also trying out kind of a new setup so that we can get these recordings onto YouTube quicker and into our community page so that they, are a little bit easier to find and for people to catch up if they end up missing the call. But without further ado, let's go ahead and get started. We have a few things on, we actually have a pretty full agenda today. But before that, very important, we have a new community member in the call. Would you like to go ahead and do an introduction?
Yes. Hi, this is Deepak Ketwal. I am Senior Principal Architect at UKG, and we are building a brand new platform. So that's why I'm looking for the new open source technology that we can leverage, and that interests me to join here. That's about me.
Awesome. Well, thank you for the introduction. Looking for the platform of the future. Obviously, you're in the right place. Here we are, but we're without the self promotion. We're glad to have you in the call.
Yeah. Thank you.
All right. Well, let's go ahead and get started. We usually like to start off things with a demo, and today we have kind of one or two of them. But the first one, I'm going to go ahead and hand it over to Jordan, who's been experimenting with a wasmCloud host written in Go that's running on top of the WAS0 runtime, which if you haven't heard of that project before, it's they call themselves a zero dependency WebAssembly runtime for Go developers. Won't steal any more of your thunder, Jordan. Go ahead and take it away.
I'm proud to stream for the first time ever. I need screen sharing privileges. Also, am I the second demo too, Brooks? Which demo do you want first?
You should do your two demos. I don't think I put the. Are you prepped to show some of the tail scale stuff?
Yeah, man, they're all stood up.
All right,
ready
then
to party.
I think we do demo or Jordan demo time to start the call, and then the second one is more of a discussion, anyways.
All right, so you want me to start with the provider?
Sure.
Okay, so this is just a follow-up. I demoed this a few however long ago, maybe 2 or 3 weeks ago. It's an implementation of the HTTP server contract using Tailscale. And if you recall, we could share, the HTTP provider to the larger internet via in Cosmonic without having to use a wormhole. Same thing locally, you could do it locally. But I've gone and implemented a few more of the features. Here's the repo. There's no README, so this is useless. The only thing we're going to show here is that there's this new value set over here called funnel equals true, and that's really all we want to show. If you're not familiar with what funnel is, Tailscale, obviously is a VPN. You have to connect to your VPN. You can access all your nodes in there. However, they have found a way to allow you to expose nodes in your VPN to the internet, which is kind of cool. As long as they had this.
Jordan, yeah. I apologize for interrupting, but you're sharing your whole screen. And so the content's kind of tiny. Could you either maximize the content or just share the tabs that you're on?
Yeah, I needed the whole screen, but I will make it for something and then for the demo, but let me see if I can.
Just might make it a little bit more readable on some of the other platforms, that's all.
All right, let's see, plus, which one of these keys is plus? Enhance. Okay, so whatever, the first tab was the repo. It's not very useful. The second tab was just showing that we have a new trait hanging off this link, and that trait is specifically this right here. I recommend go and read about it. It's pretty freaking cool. But the end result is when we start up our provider, we now get this this tag that tail scale to expose this particular node right here to the internet. So no longer do I like have to share, like you see me, I've shared it out to one other account, share these nodes out, like anyone can hit it, which is pretty cool. Now, caveat, I am using a beta library on an alpha feature. So DNS takes forever to replicate. And I only started this a little while ago. So DNS is not replicated. So y'all won't be able to hit this. However, eventually when DNS replicates, you would be able to. But a few of the things I wanted to show off was for free, because we have funnel, we'll now notice that we do have our little green lock up here. So the funnel, by implementing the funnel, we get SSL for free. And that's something we did not have last time I demoed this. So, we're getting very, a lot closer to, production ready apps. But then one of the coolest features I'm pretty excited about is, how do I get rid of this? Go away. You'll notice that I have a to-do app here. It's garbage. Don't worry about the actual front end because I wrote it. But you'll see we have buttons, and these buttons don't actually do anything. And that's because we're not like logged in here. But if we hover over logged in, we'll say, you'll see access via telnet. So we come over here, we turn Tailscale on, we refresh, all of a sudden you'll see the login's gone, all the buttons now work. And by way of traversing ScaleTail's telnet, the provider is able to pick up authentication-based things. So we'll go here, we can add to-dos, and then I actually have, there's no persistence, so if I reload this, it's all gonna go away. But just for the sake of showing off that this isn't hard-coded, I have a second account in Tailscale. If we connect it, hit reload again. Oh, here we go. This is where the demo messes with you. There it is. You'll notice that I'm now logged in as a different person. And if I create something new, I get my new little avatar. So I think, I don't know, I'm just really excited about this. It's a lot of, we have a community member named Z who works at Tailscale and is actually responsible for the entire library that I'm using, TSNet. And I can't thank them enough for helping me, with 1,000 questions. So as a reminder, funnel is alpha. You actually, it's invite only, but if you're interested, I have invites courtesy of Z. So if you want to play with it, I'm more than happy to give it to you. And the library, the TSNet library this is using is beta, so it breaks a lot. However, it's working now and it's pretty great. So I'll stop there and see if there are any questions.
So Jordan, I know that this Tailscale funnel, you can like send the URL to the public internet, so we can see it, right? We don't have to be in your Tailscale network. Correct.
So this is pretty much, if I were to give you this TSNet thing, after DNS replicated, it hasn't yet. Yeah, you'd be able to access it, and that's the whole reason I implemented like the login feature, because you'd be able to see it, but you would not be able to do anything until you connected to your Tailscale network, and then all of a sudden you'd be authenticated.
Okay, that's really cool.
Yeah, I thought it was neat. All right, and then I guess
anybody else have any other? Yeah, anybody else have questions for Jordan on the Tailscale provider? Steve?
Yes, Steve. I love Tailscale. So can you? I'm a little confused about the use case, like how about when this would be beneficial to do. Would you be able to go over that?
Yeah, no, I mean, so the use case is, I don't know. I thought this was cool. However, it's actually you that motivated me to do this, watching you all your work on the SSO providers that you have been doing. And I was like, well, we have no way with no authentication right now. And I saw this and I just wanted it. My idea is I'll put an app out there, and if you want to use it, you can connect through Tailscale. I don't know. I don't really have a good use case for it yet.
There's a phenomenal use case for this. It lets you take any device on any edge or any cloud and publish the service live to the internet securely over a P2P private VPN. That's super powerful. One, the idea that you can just hang an HTTP endpoint off the cloud. I mean, there could be, this could be on a Raspberry Pi, which is what these are right here running. And you could launch this provider, and now that device is connected immediately to the internet. The second thing is that then you also get secure authentication. So you could share something with your team or with a set of users through your Tailscale account. But that's incredibly powerful. And the fact that it's completely P2P is awesome. So I think that there's a bunch of great use cases for this.
Yeah, that's Liam Randall, my personal developer relations advocate. Anyone else? All right. Moving on to my, after I finished the provider, I took on my most aggressive wasmCloud project yet. And about 3 months ago, I bought a Raspberry Pi cluster hat. And essentially it takes Raspberry Pi, what are these little things called? Raspberry Pi Zeros, and allows you to cluster them on top of a normal Raspberry Pi. When it arrived, I plugged it in and then realized that they sent me Raspberry Pi 01s, which is ARM6 and 32-bit. And I got really sad because Bailey told me, you cannot play here. So I said, okay, fine. However, I got curious. I found, as Brooks mentioned earlier, wasro, which is a WebAssembly runtime written in pure Go without using CGO and all that nonsense. And the reason I ran with it is because on their page, they make a promise that next month they're actually going 1.0 GA. So that excited me. So I started working on it, a little wasmCloud host. And as you can see here, we're logged into Bonk. That is my Raspberry Pi 0 V1, 32-bit ARM6 and I have this Go application that I compiled down. And this is my MacBook over here. And as you can see, using Wash, I've gotten, we now have a host ID upper 25. And when I look at the inventory, we have it showing running Razero. It's not Ubuntu, it's Raspbian, but that's hard coded, so ignore it. That's also hard coded, so ignore it. I promise you it's ARM6. But one of the cool things, I've only implemented a few of the features. wasmCloud, once you start getting under the hood, is extremely complicated. I have so much more respect for the magic it does now. That being said, this little echo actor is literally the echo actor we do when we do wash new actor tiny go. And then I'm just going to put the key on it, say launch it on a host that has the version wasmCloud, right there. So we're going to send it. Over here, we see the Raspberry Pi downloading the artifacts, starting it. That is only because I'm not handling cloud events correct. It is actually running. And if we do a call on it, that's ignoring. Export. this is the Raspberry Pi doing the guest request and guest response, and I hard coded that into the actor. So that's actually the actor running right there, and that's the response from the actor. And I was really proud of this. So to recap, this is wasmCloud running an actor on a 32-bit ARM 6.1 machine, which to my knowledge was not possible before this. That is all.
Nice job, Jordan. I feel like, so I have a few questions and then I want to queue up a discussion from this.
Yeah, don't ask them too hard because my response will be ask Brooks.
That's a good loop back mechanism. So you're calling a WebAssembly module on an ARM, what is it, V61, V6L? And so, I mean, this using WAS0 in this opens up a lot of possibilities for like IoT devices that are not ARM V7 or ARM 64, which is kind of like our limitation before. What kind of Pi is this? Is it a Pi 1?
Hold on. How do I turn on the camera? Is it this one? It's this guy.
That
is
the
a
tiny
Raspberry
little
Pi.
baby computer.
Which way is the camera? There it is. Yeah, so it is the reading off the back, Raspberry Pi 0WV1.
Okay. Oh, it's a Pi 0. Wow. Jordan, do you want to talk about any kind of challenges that you ran into when you were messing with this? Like, one, I want to know if you had to do anything special around the WebAssembly runtime to like get it to work with like an existing actor. And then kind of also want to hear about if you ran into any big things that blocked you for a little while or things like that.
Boy, let me tell you. No, actually, I can't give the core team enough praise. I think Kevin published on the documentation. I think I searched for ESP32 and it brings up a create a host from spec, and he pretty much drops a checklist of all the things a host has to do there. I just followed that checklist and implemented them in line, and it's the documentation provides a chart of what guest calls and what the function fingerprint is. I did a lot of copy paste. I didn't have to figure out much, and I've never used FFIs or anything WebAssembly in my life. It was actually all very straightforward. The only issue I have is obviously this is a Go runtime and it's using the TinyGo, the wasmCloud TinyGo message bus or message pack library that y'all published. I cannot run Rust actors right now because there is some skew in the message pack decoding. I ran into it quite a bit when I was doing what's it called? Telescale providers. I ran into it quite a bit when I was doing providers, but it's a lot harder to decode when doing the actor. So yeah, Kevin.
I was just curious if the issue you were having was related to the way byte arrays get marshaled, because that's generally if I have message pack problems, it's usually from that, because different languages have different defaults for how that byte array is transmitted.
Yeah, let's see. I believe it is. Yes, I think it was, but it's let's see, wasmCloud Azure cr.io/echo. I think it's 034. I haven't done this yet, so if this doesn't work, don't be mad. Yeah, so there you go.
Yep, The unit versus array is the difference between message pack marshaling bytes as a blob versus bytes as an array. And it's weird because if you're using both of our code generators, then they both should work. But I'll follow up with you a little later and see if we can fix that.
Yeah, I absolutely. That'd be great. I actually have a branch in the interface repo that I was working on for provider has a few patches, but I don't know that I'd merge them because I don't really know what I'm doing. What else? So other than that, Brooks, that's literally the only problem I hit. One of the ways, I would start a wasmCloud host, stream the NATs next to it, and then that's how I would sanity check to make sure my host was emulating, the actual host on the wire. But once I had that, that's pretty much all I need for debugging.
That's really cool.
Yeah.
Yeah, thanks for talking about that. Or sorry, Jordan, I didn't mean to cut you off.
No, I was done.
Yeah, thank you for kind of enumerating that. I wanted to kick off a little bit of a discussion on this, and we have a few other things in the agenda, so I don't want to take too long. But I would love to just talk about what this really means for wasmCloud. You all know that way back in the day, we had, which is like anything more than a month ago is way back in the day, we had a pure Rust-based runtime for wasmCloud. And we rewrote a lot of the scheduling and orchestration bits in Elixir. So our current main wasmCloud runtime is a hybrid of Elixir and Rust, kind of getting the benefits of both. Earlier, like right before the end of the year, hopefully I'm not thinking of a different meeting, but I demoed and we've had this open source for a while, the wasmCloud JavaScript host, which is where you can run a WebAssembly module in a tab in a browser, the same one that you can run like on the server side, which is really compelling. But ultimately it's another place that you can run wasmCloud components. And then Jordan just demoed one today that's written in Go and can be compiled to a little bit different targets, more constrained targets that have more constraints around what they can download and execute and things like that. Now, I want to talk about what this really means for wasmCloud, because I want to be clear up front, like we're not planning on getting rid of the OTP host in favor of just JavaScript or in favor of just Go or something like that. It's kind of all of this is additive. And what it gives us is abilities to take wasmCloud applications to more places. And the reason it really made sense, Jordan found WasZero or was looking at it, was like, can we do like wasmCloud on this? And he was like, why? And a whole reason is because like compiling some of the Rust-based WebAssembly runtimes to ARM32 is not officially supported yet. This lets you take wasmCloud applications to ARM32 targets, or maybe even more constrained than that with Go. And it does it with a single statically compiled binary. The JavaScript host lets you do something like you cannot compile a WebAssembly runtime written in Rust, C, or Go into something that would run in a browser tab. That's what the JavaScript host is good for. You can take your application, you run it in the browser. So right now, so many of the benefits from experimenting with these different runtimes just lets us exercise the promise of WebAssembly to, run a single binary anywhere without changing it, which is really exciting. And where this all ends up landing for us in terms of a wasmCloud roadmap, which runtimes are going to be officially recommended and all of that, is all going to be the subject of experimenting and trying this out. So that was, I guess, a lot of me talking, but I wanted to kind of explain some of the background behind like why different runtimes are kind of important and what they mean for us. Jordan, I know you had that question right when I think it was like in a DM we were talking. It's like, why would we even have this runtime now that you've started, like since you started writing it? Have your thought changed at all? Do you have any more additional thoughts there?
The concept that you mentioned of getting the compute as close to the data as possible now resonates. I mean, this little toy runtime I have here doesn't actually launch providers, but I could see putting a provider like a GPIO provider that did everything there and then finally offloaded it via the network to wherever I needed it to go. So I get it now. Yeah, just doing it the hard way.
Jordan, I want to come back to something that you just CJ, I'm so sorry, you had your hand up.
Oh, no, that's fine. I just have a quick noob question. Trying to link sort of this practical demo with Brooke's sort of abstract description of these values of the different runtimes. And I'm wondering, why did was0 enable running actors on the 32-bit ARM architecture where the default runtime did not? Is it just like the default runtime hasn't been built for that architecture, or?
So I think Bailey probably has a little more information here, but as far as I know, there's nothing that explicitly restricts you compiling something like wasmTime to a 32-bit architecture. I'm pretty sure it would work, and I think it's fine. I think it's just what they call their first-party supported targets is the ARM Linux and Mac, x86 Linux and Mac, and Windows, maybe. They just have like a, it's very Rust-like where they have the super support of like level 1 support and level 2. So I'm pretty sure wasmTime would actually work for 32-bit targets fine.
Okay.
But Kevin
But
or
Jordan
Bailey,
really loves
please
Go.
correct me. Yeah, Jordan.
Gotcha.
We just give Jordan a Go possibility, and he whips something out like that.
Cool.
No, to your point, was I don't know how to say it. was0 does have listed 32-bit Linux as one of their tested targets. So I just wanted to add that.
Okay. Cool. Thanks.
I figure Bailey probably has a better perspective on the wasmTime stuff than I do. I know that for some of the other WebAssembly runtimes, they show up in Rust and Go and whatnot, but most of them have a common C base, and as useful as that is in making portable code, a lot of times what that ends up meaning is that certain compile architectures aren't easy to target without a bunch of conditional compiles and other stuff like that. So in most cases, like Brooke said, it's not that it's technically impossible, it's just that it's either low on somebody's priority list to support, or it requires a bunch of shims and other shenanigans to get to work. But like I said, I don't know I don't remember offhand if wasmTime supports that or not.
Right now, wasmTime doesn't have a 32-bit target that's part of the build pipeline, so something that it's continuously building and testing. I myself haven't tried to build it for 32-bit, although intuitively I know there's going to be some complications with crane lift. So I imagine there's work to be done there. It's not that they're not interested, but wasmTime's kind of like number one use case is really similar to ours running in the cloud. And a lot of the main contributors are focused on taking wasmTime and running it in the cloud, and less so for IoT because there are so many other runtimes that are specifically targeted for it, like Whammer and wasm3. Those two runtimes that's their first party support, and so wasmTime may add it later, but I think exploring other runtimes, we want to write portable WebAssembly modules. So we're happy to use whatever runtime is the best one for the given use case. If it's running in the browser, obviously we're going to be probably using something like V8 or SpiderMonkey. If it's running on an embedded device, hey, somebody got wasm working and we haven't gotten anything else working, wasm is going to be the one, right? I really love that Jordan was able to make that be a single binary, that without any dependencies. That just really opens the door for a lot of other things. That's really great.
Yeah, I got to come back to that because you just sort of hand waved over, like you just buried the whole lead there on pulling NATs and everything else and making that a single binary, Jordan. That is absolutely incredible. And much like the river, Jordan, that gives life to so many things, I think that your little baby here, Jordan, can give life to a lot of cool projects. I'm gonna work with Caroline on our team and have her collaborate with you on a few blogs, because this is a really amazing demo that you've pulled together here and what you can do with it. And there has been so much friction on really the whole WebAssembly ecosystem, and this is something Bailey is going to be hopefully working on later this year, is kind of fractured and spread out over many different repositories. And there's so many people that are really passionate and excited and working on moving WebAssembly forward, but to navigate it, you sort of have to visit all the right meetings and talk to the right people and join Zulip and Slack and Discord and have the right conversations. And you're just helping to make it so much more inclusive, so much more accessible, so much easier to use. Don't hand wave on what a slam dunk or grand slam that you really just pulled off here. There's Michael Jordan and then there's Jordan. So I'll stop now. If you come on camera, I want to see how red your face is.
Pass.
All right. Well, I think that this has spawned a lot of possibilities, a lot of exciting things for wasmCloud on edge devices could look like. I just want to reiterate and thank Jordan for actually getting down and experimenting with this, because this is really cool, and I'm looking forward to seeing how this evolves. And I'm saying that in a little bit of a passive way, not to say that Jordan is just gonna implement all the things slowly over time, but I would love to come up with like a demo or example that would really show off using an embedded device like Pi Zeros really well, and then get that working with this, because this would be a really cool thing to show. All right. Well, in the interest of time, maybe just one more question if anybody else has anything, and then we'll move on to the rest of the agenda. All righty. So getting on to the next parts of the agenda, we have two big releases that we've cut in the wasmCloud organization over the past few days. One of them is a release candidate, and the other one is Wash 0.14. And so I really just want to talk about both of those, but kind of in their own context. So let me go ahead and share screen really quick. One of them that we released recently was wasmCloud OTP version 60, but release candidate 1. Now, using a release candidate isn't something that we've done before for the wasmCloud host. We've used alpha releases in Wash so that people can download newer versions, get used to like some of the features that are breaking changes, and test them out before we do a full release. But wasmCloud has always been complete releases. So I want to touch on why we're doing it and kind of what this means. So I haven't really used, release candidates were kind of new to me until semi-recently, and so it may be new to you as well. So what this means is we have a collection of features for version 60 that we want to release for wasmCloud. But this version of the host is kind of especially big on the not necessarily outward breaking change, but it had a very large factor in the supervision tree, which essentially allows you to run multiple logical instances of what you think of as a host on a single wasmCloud host. I know it's a little turtle-y, but you can run multiple different hosts in a single wasmCloud process on the Beam. Kevin did a little demo and talked about that, and may want to add a little bit more color to that description here in a moment. That was a very large refactor in and of itself. It's gone through many different refactoring passes. Again, thank you to Giuseppe for doing a lot of these credo warnings, and none of those change functionality. But especially the supervision tree refactor and converting the lattice cache, which was previously stored as a NATS stream. It's where we put link defs, claims, all those things. Link defs will actually go and be stored in a NATS key value store instead of a NATS stream. And this is so core to the wasmCloud experience, link definitions, that we wanted to make sure that we could cut what we call a release candidate, run through some tests, see, make sure nothing has drastically changed before we officially release the 0.16. So anybody who's looking at this isn't going to be pulled in automatically to Wash or any of the things that you've done for wasmCloud yet. But if you're interested in testing this out, please feel free to, you can grab the tarball from this release. Feel free to run some tests on it. But just to note that we're going to be either when we're running through our tests, if we find some things that we need to fix, we'll put in a PR and probably release a release candidate 2. But as soon as you see that this is version 60, then that means we've gone through a little bit more tests than just our automated pipeline. Kevin, did you want to say any more details about some of the big breaking changes and why we have a release candidate?
Let's see. So, I mean, you covered some of the stuff with link definitions. I kind of went into that a while ago, and we had the short version of that is we started using NATS streams for the lattice cache before NATS had a key value store built in. So this was basically just us making the official change to use the more recent version of the key value bucket. It also, it's a subtle difference, but what it means is that you can query the link definitions and claims cache from any given lattice without having any of the hosts running in it. And that makes a pretty big difference when you're trying to run, multiple hosts in production. And then, like you said, the supervision tree refactor was all about making sure that, I don't know if you remember the so-called old code base, there were a ton of assumptions about global state, and we were storing a whole bunch of things globally, which made some of our tests very difficult to run, and we had to run them in sequence and things like that. And so one of the big goals, in addition to just being able to run multiple versions of things, was to make sure that when we spin up a virtual host inside that process, we get everything isolated and it's all self-contained and self-controlled.
Yeah, that makes sense. Anybody else have any other questions about this wasmCloud release? Sweet. Well, then one more thing I wanted to talk about our latest and greatest release of Wash, which is version 14. I dropped a couple notes for this in the community Slack just because, well, if you look at what's changed, it's been a little bit. A couple of things have gone into this version of Wash. Many of these things actually related to things like CI and internal things. They're not all breaking changes, but just to give a general overview of the big things that changed in Wash 14, once you go to download it, it's already released on Brew and all the package managers and everything. So you should be able to upgrade with your method of choice. But some of the big things is we've actually dropped the OpenSSL dependency in favor of using Rust TLS everywhere, which has been really sweet for portability and not running into issues compiling wash and then running it on a newer version or a newer operating system that has a different OpenSSL version. Some people have run into issues with wash when pushing to GitHub container registry, where if your GitHub username has capital letters in it, that actually technically isn't allowed in the OCI spec. It's supposed to be all lowercase, but that led to some friction that we actually fixed. Everything is just lowercase. And last but not least, some of the biggest changes that have gone into this version has been migrating some of the functionality from the actual wash binary to the wash library. And if you actually go to crates.io and take a look at wash lib under the documentation, we have a ton of modules in here that actually supply the functionality behind wash. So if you're doing something, if you're working in your own Rust project and you want to embed some of the functionality that Wash has, you can do that now with the reusable crate. A lot of that is there, and that's been really a cool evolution of the Wash code base. So general call to action to go check out your latest and greatest Wash version, and let us know what you think. No big breaking changes in terms of we didn't change all the subcommands or anything like that. All right, well, that is all that I wanted to, yeah, Stephen, you can remove all the 2 lowercase things now. That is all I wanted to talk about relating to a couple of big releases that we've had in the open source side. For the last portion of the call, I think I'm actually going to hand to Liam for a little bit. We're going to be, wasmCloud implements many layers of security, starting with deny by default, and then almost everything that you do around actor invocations, starting WebAssembly modules goes through multiple checks for securely knowing what you're starting, what you're invoking, if you're allowed to do it. And by you, I mean like a principal. But I don't think that we have a really good, just high level view of all of those different layers in our documentation. And that's part of what's kind of spurring this discussion. So Liam, I won't step over your process, so I'll just go over and hand to you.
Great. There was a brief conversation on wasmCloud Slack today where someone was asking about security, and they said they were going to be able to join today's call. So I hope you're on. I'm not sure who it was, honestly, on your Slack name. But what I've done is, and we're working on a formal white paper here for this. But I've taken all the different layers of wasmCloud here, and I've kind of laid them out. And what I wanted to do was just have a quick discussion here where we talk to the layers, and I'm hoping that maybe Bailey and Kevin can help me out by creating some tickets or filling out the sticky notes here as we go through the stack, and also jump in and collaborate as well. This is a Miro board we're just have shared here in our Slack behind here. I'll put the link internally again, or the link should be there if anyone else, Brooks, you want to jump in. All right, so the first thing I would want to start by calling out is, let's just give me the overview of what the layers are we're going to go through here. So we're going to start by talking about the security value propositions that WebAssembly itself brings to the table. Then we're going to talk a little bit about what WASI adds in its model and maybe introduce some of the component model stuff. Then we'll add the security layers that are added by wasmCloud. The security approach, contract-driven development that we get with capability providers, with actors, and then finally by running wasmCloud in clusters. And then I think there's a sidebar here where we can kind of talk about how taking all of source code out of your projects and just writing business logic is the ultimate security innovation, which is really aligned to the component model now, because that is makes developers responsible for so much less. So let's start here at the wasmCloud layer. And the first 3 things I would call out would be, one, you get sandbox code. So if you guys could fill these out as we go through. The second would be the WebAssembly layers are reactive. The third security value proposition you get is that it's denied by default. So by default, there's a hard boundary between your host and your host operating system and your guest modules that are running WebAssembly here. Kevin, Bailey, anything, or Brooks, anything else you guys would add, or anyone on the call that you would jump in and throw out as big security innovations here?
Yeah, I would.
Sorry, go
I would definitely push for the linear memory. Like basically, you're able to validate a WASM module before ever executing it, and part of that is also proving that a valid WASM module isn't able to access memory outside of its linear memory constraints. And the fact that it is a valid WASM module and can compile as WASM basically means that it's memory safe. Go ahead, Kevin.
Very cool. One that I just thought of on the fly was that WebAssembly has a security model that's portable outside of Linux. It's not tightly coupled to an operating system. The security model works on edge devices, on Linux, on Windows, on Mac, even inside of browsers. I think that is hugely powerful when we think about things from there. Sorry, Brooks, did I interrupt you?
No, but Kevin started talking. Kevin, you go ahead.
Yeah, I was just going to add to what Bailey was talking about at the low WebAssembly level is so actually there's another good question in there from Justin that I was going to talk about, which is a number of things that WebAssembly enables at the low level or prevents at the low level are things like buffer overrun. So a typical way to attack software is to cause it to crash and then execute the instruction that you've left dangling in memory. And then you then have control over that process. That's physically impossible in a WebAssembly module. If something reads beyond the end of what exists, it will cause a panic or a trap. But you cannot physically execute code, byte codes that are sitting in a data segment. So it's a subtle distinction, but in regular processes, I can tell you that the value at this memory address is an opcode to execute, but you can't do that in WebAssembly. The only things that are executable are lines of code that existed in the module when it started. The module can't be modified at runtime, and yeah, you can't insert assembly. If I'm understanding Justin's question right, you can't actually insert code into the WebAssembly module in order to make it do things. And then this runs into another part of the defense in-depth approach, which is even if you could do buffer overruns or get a WebAssembly module to execute your opcode rather than what it's supposed to, it still doesn't have access to do anything malicious because of the other sandboxes.
Phenomenal points, Kevin. Let's try to turn those into notes, and let's go ahead and move on to the WASI layer, because I do want to try to give a comprehensive overview as to how these layers fit together here. With WASI, we really have a couple of innovations that we embedded into Cosmonic, but let me go ahead and talk about them now at this layer. The first one I would draw out would be capability-driven security. Where now with the component model, you can start by writing contracts for what your code segments look like, and then swap those across different languages or different implementations of those contracts. The second thing I would call out, and please feel free to rephrase, Kevin or Bailey, if you feel like my notes here are a little off, would be that these are now composable, because the ability to switch and use a contract that was, say, written in Rust with a contract that was written in C means that you can start to, hot swap different languages that are there. Are there any other things with WASI, Bailey, Kevin, Brooks, anyone on the call that you guys would throw in here?
Yeah, just making sure nobody else had their hand up. I think one of the fallacies that people have is assuming that WASI is like POSIX for WebAssembly. It isn't. And more importantly is that even though there are imports in WASI that allow you to do things like read to and write from files, or I'm not sure where it shows up, but opening a socket or accessing a socket, those are still operations under the authority of the host. So the host still gets to tell you, no, you can't access that file. No, you can't access that directory. No, you can't access this file descriptor. It can even block you from writing to standard out. So there's still more control and essentially unlimited lockdown capability based on the host.
Bailey, anything you'd add here?
I have plenty to say, but
yeah.
I do think I think it's pretty interesting that that was the point that Kevin raised, because it was actually me and Brooks this morning that were talking about how it's kind of regrettable that WASI is often compared to POSIX. It's like it's the closest allegory that we have, but what we're really doing is designing something completely new that is capability based. And so when we say that, we mean every single API is essentially a capability that's granted by the host. And I'm basically rehashing things that Kevin just said, but with my viewpoint on it, in that, like, in a lot of ways that's kind of like POSIX, but because it's capability driven. And the key part here is I put deny by default in the WASI space and less so in the WebAssembly space, because in WebAssembly, it's denied by default because the capabilities aren't there. And it's denied by default in WASI because this is what introduces those capabilities, like being able to open up a socket and what files you can read, and being able to start a thread, like a lot of that stuff. That's where we're iterating and innovating. And so with WASI, we're coming up with the APIs that are based around granted capabilities.
Great. And Kevin, I love that you're just running ahead down the list here with the wasmCloud innovations, because I know this is where you've invested a significant amount of your time is thinking through the microservice and application model here. So running down your list, a tamper-proof module that gets signed by keys. I would put that it can be verified with issues and signers, even when you're offline. That's one of the advantages to the encryption scheme that we've chosen. Explicit capability allow list, extensible policy application based on JWTs. JWTs expire and are verifiable offline as well. Again, I'm speaking to the value props. Invocations are signed as well. Isn't that correct? What else would come out on that list here for the things that wasmCloud adds to the ecosystem from a security perspective?
Yeah, I don't know if this is like a bullet item, but I guess the inciting event that got me thinking about how to properly secure WebAssembly modules was I was doing work on the Docker notary system, and basically you could set policies that says this Docker image can do these things, but you have to consult the notary to get that validation. And the image that you're referring to has no embedded security information. So what I wanted was to be able to look at a tiny WebAssembly module and figure out from the module itself what it can and cannot do without having to consult either a central authority or an online authority.
Super solid there, Kevin. Let's maybe try to see if we can get through this. I know we're running tight on time. Hope folks can stay with us for another minute or two, because I think we're going to kind of wind down here as we move up to stack. Now, for
really
my
quick, Liam, I have one more that I'd love to throw in for the wasmCloud side. Just want to distinguish the signed invocations. We both have an invocation hash to make sure it hasn't been tampered with in transit. And we know that the invocation came from a valid source in a wasmCloud lattice because it's signed by a cluster seed. All of the hosts in lattice that communicate with each other have to have the same set of allowed cluster issuers, which kind of sounds like the verifiable issuer / signers, but there is a difference between the issuer and signer of the WebAssembly artifact and the issuer and signer of an invocation. We do it for both. So I just wanted to make sure that we had that down. Thank you, Kevin, for updating that sticky. You can't just, for lack of a better way of saying it, yeet a NATS message into a lattice and then start invoking stuff willy-nilly.
All right, super. Well, let's go and move on to capability providers if we can. Now, capability providers are very much in the model of what the component model represents here. So here I would maybe open the floor and say, Kevin, Bailey, what additional things do we add here, maybe that we inherit from Smithy or the validation that we're doing in our contract-driven development that we might want to call out here? Signed with capability claims. Okay. Oh, you're moving ahead there. I'm sorry. On capability providers. So nothing additional except that we've adopted the Smithy tooling. So it makes modeling capability providers at scale. It uses the exact same set of tooling that AWS uses itself to model their cloud. That's
the security though, is it? The Smithy stuff?
I think there's some derived security benefits from ensuring that you can have your code be a part of a broader ecosystem. I think that is the sort of value props that I would call there. Sliding on up to actors, or Kevin, did you want to maybe jump in here and start on your couple actor ones you laid out?
I didn't lay out any of the actor ones.
Who did the signed capability claims? Is that you, Brooks?
It was me.
Oh, Bailey, you're my next guest for what it's worth.
I mean, so much, of course, for the wasmCloud cluster is, copy paste from a lot of what we were doing here with wasmCloud, right? But it's the end-to-end security that you get from the combination of all of these pieces that you have before. So I feel like when you talk about this cluster, the first thing that came to mind for me was, you basically have proof of stake throughout the entire ecosystem. So I don't know I'm jumping ahead really to the red here. But signed with capability claims is another way of saying that not only is it, do we say what you're allowed to do, but we also sign that that's what you said you were allowed to do. So you can't give yourself more power than what you were granted when you were built.
Wonderful, Bailey. Thank you so much. Okay, so a couple here for the actors, stateless. It goes along with the reactive approach that we find in WebAssembly in general. And then I wanted to speak to a couple security innovations that I think you get from thinking about wasmCloud as part of an ecosystem of distributed clusters. And here, I think we really transfer into the abilities of software. When you want to achieve security propositions like reliability, availability, you start thinking about running my code in multiple regions, in multiple VPCs, multiple clouds, multiple devices. And this is where wasmCloud, I think, shines the most because of the stateless approach that you get in the actors, being able to hold state and capability providers, you now have simple knobs that when you want more compute, whether it's just more instances for more throughput, or where you want more availability or more reliability, you can simply just spin this up in more places. And if you've seen any of the Cosmonic demos that we do out in booths, we'll be at ShmooCon next weekend, and we've got a really lively schedule this year already. That's a key one that we really emphasize quite a bit, that we inherit just from WebAssembly. And I know we're so tight on time here. Whoever's putting these couple down, can you just jump in on those? And then I've got maybe one or two more to add, and we'll wrap this up. And I thank everybody for staying a couple minutes over.
Sure. The ones that I put in there, just real quick, some of the things that we tend to take for granted within a Lattice or a wasmCloud cluster is that every node in that cluster knows which other node issuers are supported, and is itself an issuer. So even if someone were able to compromise your infrastructure, compromise your NATS infrastructure, gain access to the Lattice's topic structure, and then issue fake invocations on your Lattice, all the hosts would reject them.
Yeah, those are phenomenal. And let me just throw a few in here at the end. The biggest thing to me, and what inspired me to fall in love with this project when Kevin pitched it to me, God, 3 or 4 years ago when we were at Capital One, was write less code, maintain less code. And I think this is the biggest thing that we actually contribute to, because developers today spend 80% of their time on operations and maintenance. And what that means is that you're not spending your time delivering new features. Additionally, because of all the contract-driven development that you get underneath this, you now have hot swappable capability providers, meaning that you can move to any cloud or edge, including your own, all without changing your code. So, and then the only last thing I'd maybe throw in, if we zoom way out here, we've got a few big ones, like much of the tooling and ecosystem is written in Rust. That I think applies all the way across the board. So we're sort of following those new, NSA, even the NSA recommends that people start to move to memory safe languages like Rust. We do have this coming in a white paper here soon. I'm actually reading most of this from the white paper, which includes a lot more detail on this. So be on the lookout for that soon. And thank you everyone so much for staying late on today's call. Brooks, I'll hand it to you, and you can go ahead and read us out.
All right, everyone. Yeah, just reiterating, big thank you to coming. Great call today. Really, really awesome agenda. And really looking forward to next week. This call has actually been successfully streaming to YouTube unlisted, which is great, because right after we wrap up, I can actually go and grab the URL and drop it in our community page, and it'll be on the website. So looking forward to doing this from now on. Anyone who actually came and is watching the live stream on any of the various sources, thank you for coming. We're probably going to start doing things like tweeting out and letting people know that these things are actually happening, so people can attend. But with that being said, I think we can go ahead and stop recording, and